In the fourth section here, we're going to look at linear functions with respect to their intercepts. So first of all, what does that term even mean? Intercepts are the coordinates of points where a line crosses each axis. So usually, again, if we have an oblique line like you see in the example off to the right, there's going to be one point where it crosses the x-axis, and there's going to be one point where it crosses the y-axis. Those are what we call intercepts. So for the next part here, where does this line cross the x-axis? Well, that happens over here. So we should be able to say for the x-intercept, this is the point -3, 0. Where does this graph cross the y-axis? Well, it happens right there. I don't know, can you see the purple? Let me put that in red also. So for the y-intercept, we would say this is the point 0, -2. We've talked about before, there is no easier number to substitute than 0. So that's exactly what we're going to do with the algebra part of this to find the x-intercept, to find the y-intercept. If we're not given the graph, it's a matter of, to find the x-intercept, we are going to substitute 0 into the equation for the y and solve for x. To find the y-intercept, we're going to substitute 0 in place of x and solve for y. So again, basically just do the other one. To find the x-intercept, and again, that number could be just about anything, we're going to substitute 0 in place of y. To find the y-intercept, we're going to substitute 0 in place of x. So if they give us the equation here in guided practice number 1, where it's 2x plus 4y equals 16 with no graph, it's no big deal. So if I want to do the x-intercept first, I'm going to write 2x plus now 4 times, instead of y, I'm going to substitute 0 in place of that variable, equals 16. And again, that should make things easier for us, because out of the 3 terms we started with, one of them should just disappear. So that means my x-intercept has to have coordinates 8, 0. I know that the y coordinate is 0 because that's what I substituted. And then go the other way. To find the y-intercept, we substitute 0 in place of x. Leave the y. As a matter of fact, we're going to solve for y. That gives me 0. Divide. So this tells me my y-intercept for that line happens at 0, 4. Again, you're solving for the one variable because you've substituted 0 for the other one. Let's do another one here. Find the x-intercept for the line with the equation. Careful, ooh, they didn't write that the same as the first one. Just be careful about where you're substituting. So it's negative 2y is equal to 6 times 0. No, that's not right. If we're going to find the x-intercept, we substitute 0 for y. So it's negative 2 times 0 equals 6x minus 8. Well, yeah, 2 times 0, negative 2 times 0 is 0. Always reduce. Now again, if the question simply asks you to find the intercepts, we're okay leaving that as a fraction. 4/3, comma, 0. Now, if we have to graph it, leaving it there as an improper fraction, that's going to make things a bit challenging. If we have to graph it, then we'll put it in a different form. If all we have to do is state where the x-intercept is, where the y-intercept is, it's okay to leave it like that. Then for the y-intercept, we set x equal to 0. We substitute negative 2y is equal to 6 times 0 minus 8. Well, this time, that gives you 0. 0 minus 8 is negative 8. And divide. Careful, we're going to divide by negative 2 this time. Negative divided by negative is positive. 8 divided by 2 is 4, so our y-intercept here is at the point 0, 4. Part of the reason that we use intercepts is that it makes graphing much more accurate. If you have graph paper, okay, that's not too bad. If it's just a plain piece of paper, well, then it gets challenging. So if you're given the equation of a line and you are asked to graph it, one of the easiest things to do is to find and plot each intercept. And then draw a line. Basically, like connect the dots. Now, there are a couple of different things. We'll take a look at examples as we go through here. But there are a few things where you've got to be careful because the origin is both the x-intercept and the y-intercept. And you can't graph a line with just one point. If that happens, then you're going to have to substitute. Let's try the next one here. 4x minus 10y equals 20. Graph this using the intercepts and show your steps. Okay, so for the x-intercept, again, we set y equal to 0. So 4x minus 10 times 0 equals 20. Sorry, that's supposed to be a 0. So again, that becomes 0. 4x is equal to 20. Divide both sides by 4. So my x-intercept is the point 5, 0. So that means I'm going to go to the right 5 spaces, and that's the point 5, 0. Then for the y-intercept, zero is what we substitute for x. Careful of the negative. Negative 10y is equal to positive 20. Divide both sides by negative 10. Positive 20 divided by negative 10 should be negative 2. So the y-intercept is at the point 0, negative 2. So on the y-axis, down 2 spaces. Now we have 2 points, and we should be able to draw our line. And it should be that easy. Let's do another one. Take a look at y is equal to 3x minus 9 using the intercepts. So again, for our x-intercept, we set y equal to 0, so 0 equals 3x minus 9. Well, now I need to separate things here, so I would say I would add 9 to both sides. 0 plus 9 is 9. But again, I don't want to know what 3x is. I want to know my x-intercept. I need to divide by 3. 9 divided by 3 is 3, so the x-intercept is at the point 3, 0. For the y-intercept, y is equal to 3 times substitute 0 in place of x. Well, that was pretty easy. Remember, if it's written in this form, y equals mx plus b, that constant at the end is the y-coordinate of the y-intercept. So I need to plot the point 3, 0 as my x-intercept and 0, negative 9 as my y-intercept. And again, I get another line just like the first one there where it's a positive slope. It's definitely going uphill. Now again, I don't much care if your line is perfectly straight or not. I have the work off to the side that clearly shows I'm trying to draw this line that goes to the point 3, 0 and 0, negative 9. Let's practice some more. Graph each equation by finding the intercepts first. Okay, so for the x-intercept, y-intercept, and do the work. And as a matter of fact, let me do it the other way. Substitute 0 in place of y. So 8x minus 3 times 0 equals negative 24. 8x equals negative 24. Please write out the steps. Please show your work. You may use a calculator for some of these, and that's not a problem. Not showing the work, that's the problem. So -3, 0 is our x-intercept. For the y-intercept, 8 times 0 minus 3y equals -24. -3y equals -24. Sorry, used too much space up above. Negative divided by negative is positive. 24 divided by 3 is 8. So this is the point 0, 8. So again, if I plot -3, 0, that's from the origin, 3 spaces. Left. And then my y-intercept is all the way up here at 0, +8. And again, as we look at the line going from left to right, it's going uphill, positive slope. Number 2. Are we getting the hang of the fact that when we do the x-intercept, it basically makes that y term disappear? And when we substitute 0 in place of x to find the y-intercept, it makes that x term disappear? So maybe we can speed this up a little bit, maybe not quite use so much space. I know that's going to turn into a 0, and then divide both sides by 7. 14 divided by 7 gives me 2. The x-intercept is at 2, 0. To find the y-intercept, again, substitute 0 in place of x. 7 times 0 is 0. That first term disappears. Do the algebra, finish it out. Y is 7 when x is 0. So my y-intercept is at 0, 7. Plot those points. The x-intercept here is at 2, 0. The y-intercept is up at 0, +7. Play connect the dots. I should have a line that runs downhill. And there we have it. And again, we'll talk more as we go along here about making these connections between what we talked about with slope-intercept form of the equation of a line, slope of a line. Let's take a look at number 3. Well, for the x-intercept, when we set y equal to 0, things don't get much easier than that. It's the point 8, 0. Okay, the y-intercept is going to take a little bit of one step of work. Positive divided by negative is negative. 8 divided by 4 is 2. So my y-intercept is at 0, -2. Positive slope, but not nearly as steep as we just saw there with number 1 or number 2. Number 4. Oh, That's a very simple equation. So again, for the x-intercept, x equals, well, -6. So the x-intercept is at -6, 0. Now here's, again, a place where people just go too fast and get into problems. If I substitute 0 in place of x, again, that first term disappears. Careful, it says -y equals -6. So that means positive y is +6. The y-intercept here is at 0, 6. Please be careful with your graphs. Also, don't just go and play dot to dot and stop. We're trying to find, in the most convenient way possible, points that are on this line. We're trying to write out coordinates of points that are on this line. But every line has an infinite number of points. It's not just these two. So make sure that you go past the points that you plot, go through the x-axis, go through the y-axis, and make sure that you're putting arrows at the ends. Oh, look at what's happening here. Again, for my x-intercept, this completely disappears. So 6x equals 3. Divide both sides by 6. Uh-oh, fractions. 3/6 reduces down to 1/2. Now again, positive divided by positive is still positive. So this is the point 1/2, 0. Well, that's going to be kind of interesting to plot that one. And for the y-intercept, again, this disappears. -y equals +3. I don't want to know what -y is. I need to know what +y is. So if -y is equal to +3, divide both sides by -1, +y equals -3. So this is the point 0, -3. Now with this graph, yeah, the 1/2, 0, things are getting harder to plot here. Take your time, be careful, do the best you can. This one turns out to be very, very steep. Let's take a look at number 6. Oh, this is what they warned us earlier. The x-intercept is at the point 0, 0, which means the y-intercept is also at 0, 0. Again, for the x-intercept, what's the x-coordinate when y equals 0? Well, in this case, y is 0 and x is 0. That means it goes through the origin. 2 points determine a line, not just one. We need to pick something else. Say what happens when x equals 1. Then we're back to where we started this whole unit here. Just do basic substitution in the original equation. 4 times 1 plus y equals 0. Well, 4 times 1 is 4. Solve for y. So when x is 1, y is -4. That gives me a second point that I can plot. So every time that you have a line that goes through the origin, that goes through 0, 0, then you're going to have to substitute and find the coordinates of a second point on your own. So again, if we can't substitute 0, in place of x or y. Pick something, again, that's going to make things easy. In this case, for number 6, yeah, substituting 1 in place of x, that was pretty easy. What happens with number 7 here, where it says x equals -5? Well, okay, that means, well, our x-intercept is at -5, 0, but there is no y-intercept. Because there is no y variable. That means, well, this line goes through the x-axis, and we know it goes through the x-axis at -5, 0. But if it doesn't go through the y-axis, that means, well, it can't have a positive slope because otherwise it would go through the y-axis up there. It can't have a negative slope, otherwise it would go through the y-axis down here. Anytime you see an equation where it's just y equals some constant number, this is a vertical line. And again, if there is no y-intercept, that means it has to stay parallel to the y-axis. Well, the y-axis is vertical. This line is vertical. And then for the last one here, -5x, find our x-intercept. The y term completely disappears. -5x is equal to -5. Don't rush through it. -5 divided by -5 is +1. So my x-intercept is at 1, 0. For the y-intercept, again, careful when doing the dividing, whether it's positive or negative, makes the difference between the right line and the wrong one. So we're back to, oh, this is awfully hard to graph. Let me zoom in a bit here. Because my x-intercept is at 1, 0. My y-intercept is at 0, -1. Those are awfully close together. Connect the dots. Again, don't just stop at the intercepts. Keep on going. Okay, so again, that's how to find and how to graph different lines here using the intercepts method. Again, there is no easier number to substitute than 0. So to find the x-intercept, we substitute 0 in place of y and solve for x. To find the y-intercept, we substitute 0 for x and solve for y. See you in class.